graphing cotangent. I am going to modify this just a touch from what's on your table. I think I might just go to pi, and I think that'll give us enough of what our graph looks like and help. Unless you want me to go all the way to 2 pi, I'm happy to. I can. I was trying to be nice, but it never works out. Okay, so at 0, cotangent is the reciprocal of tangent. So tangent of 0 is 0. That means cotangent would be undefined. At pi over 4, tangent of pi over 4 is 1. So cotangent would be 1. Pi over 2 is like 90. Tangent of 90 is undefined, so cotangent would be 0. 3 pi over 4 is quadrant 2. Tangent and cotangent are negative, and it would be a negative 1. At pi, if you need to, you can always go back to this picture. This is the point negative 1, 0. Tangent is y over x, so cotangent would be x over y. Negative 1 over 0, undefined. Alright, so I'm going to put my points. Got my pi over 4, pi over 2, 3 pi over 4, and pi. When it's undefined, we put a vertical asymptote. Pi over 4, the point was 1. Pi over 2 is 0. 3 pi over 4 is negative 1. And pi was undefined, so vertical asymptote. And the graph will look like that. It's a curve approaching your asymptotes, not actually touching them. You'll notice, just like tangent, the period of cotangent is actually just pi. That's the length of time until it takes repeat. If we graph this thing all the way to 2 pi, you'll just see it doing the exact same thing over again. So tangent and cotangent have a period of pi. What we need to keep straight for these, we pick different intervals to help make our graphs nice. With cotangent, we went from negative pi over 2 to positive pi over 2. With cotangent, we are going to go from 0 to pi. When we graphed our tangent yesterday, it was an increasing graph. And if we graphed our cotangent, that one is decreasing. So they look the exact same, except flipped. Okay? So this is what you need to remember for tangent and cotangent. Whether the graph is increasing or decreasing in that interval. Both of these just have a period of pi. The domain of this, let's just identify our domain by talking about what x cannot equal. So I'm going to put dot, dot, dot because we know it extends both directions. It can't equal 0. Pi, what would be the next one? 2 pi, 3 pi, and so on. So it can't be those multiples of pi. What's the range of our cotangent graph? It hits every y value. So negative infinity to positive infinity. We've also been talking about if our functions are even or odd. Even means symmetric to the y-axis. If I fold this thing on the y-axis, does it overlap itself? No. Odd is symmetric to the origin, meaning if you flip over both the x and y, it would overlap. Yes. So just like sine and tangent, cotangent is odd, which means if you have cotangent of a negative, you can pull the negative out in front. questions? So for the rest of the day today, we're just going to graph tangents and cotangents. We'll go through the same list of information that we did with sine and cosine. So amplitude, period, count by. Interval I'm going to recommend on just about every problem. It just seems to make these a little bit easier. And otherwise everything stays the same. So the first one, y equals tangent of 2/3 x. So the amplitude, just like before, amplitude is your coefficient of the trig function. So this is just a 1. Period is going to be a little bit different for tangent and cotangent. For sine and cosine, we did 2 pi divided by the coefficient of x because it took a length of 2 pi before tangent or before sine and cosine repeated themselves. How long does it take before tangent and cotangent repeat? Pi. So it will be just pi divided by the coefficient of x. It should give me 3 pi over 2. Okay, count by. Count by is your period divided by 4 for the 4 quadrants. So 3/2 divided by 4 gives me 3 pi over 8. I am going to go ahead and do an interval here. With sine and cosine, I said you had to do it if you had something added or subtracted with your x. And that's still true. But because I don't start at 0 for tangent, it's typically just a little bit easier if we go ahead and do it and make sure we're on the right track. Where do we start and stop for tangent? Negative pi over 2 less than or equal to 2/3 x less than or equal to positive pi over 2. So if I want to solve for x, I'll divide everything by 2/3, or think of it as multiplying by 3 over 2. So we get negative 3 pi over 4 less than or equal to x less than or equal to positive 3 pi over 4. Okay. So now we are ready to graph. My first point will be at negative 3 pi over 4. Plus 3 pi over 8 is negative 3 pi over 8. Plus 3 pi over 8 is 0. Plus 3 pi over 8 is positive 3 pi over 8. Plus 3 pi over 8 would be 6 pi over 8 or 3 pi over 4. We pick this interval because we know what happens at both ends. My amplitude is 1, so I'm going to put a point at 1 and negative. Okay, then if we think about tangent. Tangent starts low and goes high. So, I have my asymptote. The next point will happen at my negative amplitude, so negative 1. The center point is always at your 0. The next point is at your positive 1. Now remember, this is a curve, not just a line. Getting closer to your asymptote. So it should look like that.
Why did we stop at 3 pi over 4 instead of 2 pi over 2?
If when we did our interval, that's where it should have came out, and then when I added my count 5, that's the last point I got. Other questions? Let's do some more. Y equals -1/2 tangent of 2x. Okay. Amplitude. One-half. What else is happening on this one? Period. Pi divided by 2. So the count by is our period divided by 4 pi over 8. Interval you wouldn't have to do, but I think it's just easier. Tangent typically goes from -pi over 2 to positive pi over 2. If I divide all those by 2, I get -pi over 4 to positive pi over 4. So -pi over 4 is the first point. Plus pi over 8 is -pi over 8. Plus pi over 8 is 0. Plus pi over 8 is positive pi over 8. Plus pi over 8 gives us pi over 4. Amplitude is a half. We know, we picked this so that we have asymptotes at both ends. Then tangent typically starts down low and rises. But because we flipped it, it'll start at its high point, which will be at +1/2. The center point is always the 0, and then we go to the -1/2. How do we feel about this so far? Let's do a cotangent one. Make sure we're okay with that. Amplitude, period, pi divided by 1/2, which gives us 2 pi. count by is our period divided by 4 for the 4 quadrants. We get pi over 2. Okay, we wouldn't have to do the interval, but why don't we? Where do we normally start and stop cotangent? Start at 0, end at pi. So divide by a half or multiply by 2 and we get 0 to 2 pi. So my first point will happen at 0, adding pi over 2 every time. So pi over 2, pi, 3 pi over 2, and 2 pi. Amplitude is 3. We pick the interval for cotangent for the same reason we pick tangent's interval, because we can automatically just say both ends are asymptotes. Then, cotangent is decreasing. It starts high and goes down low. So at pi over 2, we would be at positive 3. Then we'll come down to 0, then down to negative 3. I want to do one that involves moving maybe up and down, left and right as well, so throw a few more things in the mix, and if you're still okay after that, then I can stop for today. Let's do this one. Should I be worried that you guys have coronavirus now? Send you home. Alright, what's my amplitude? 1. Period. Pi. Pi divided by 1 is still pi. So count by period divided by 4, pi over 4. What's this 3 doing to my graph? And what else do I have to set up? It's cotangent, so that means 0 to pi. I'm going to solve for x here. So I would subtract pi over 2, so I get negative pi over 2, less than or equal to x, less than or equal to pi minus pi over 2 is pi over 2. Let's do 2 periods. I think let's have 2 periods in this one. I'll go ahead and just do the first period to start, and then I'll tack on the second one. So first point was at negative pi over 2. Count by pi over 4. So plus pi over 4 is negative pi over 4. Plus pi over 4 is 0. Pi over 4, and 2 pi over 4 is pi over 2, which is where we said our first interval should stop. Because my graph is going up 3, just like we did with sine cosine, we're going to go to positive 3 and draw a dashed line for our axis. We also know that both ends will be asymptotes. My amplitude is 1, so we'll be going 1 above and below this dashed line that we have. Was I graphing tangent or cotangent? Cotangent. Cotangent starts at its high point, so at negative pi over 4 you should be at 4. At 0 you hit the dashed line, at pi over 4 you come down to 2. I asked for 2 periods, so we need 4 more points on the end. So just add your pi over 4, 3 pi over 4, pi, 5 pi over 4, 6 pi over 4 is 3 pi over 2. You have asymptotes at the beginning and the end of that interval. And the pattern continues. So 1 above, 0, 1 below. Do we need more samples? Okay. The assignment, I'm not going to do the last ones. So the first bit's matching, and then you have your graph.